We'll proceed in calculus, pseudo calculus problems. Okay, pseudo calculus problem. We are pursuing discussion. I believe we can wind up this area and circumference concept where we have came up to a fundamental how to calculate surface area of a circle and how to calculate circumference of a circle through different way. And that different way is cutting, dividing the surface area. Okay, dividing the surface area into n number of parts and then calculate the area of each part and then add it. That is one of the way anyone can think about pseudo calculus problem. How we can solve a problem in a fashion that is not calculus. And then we come to a conclusion that sorry. I think we should use calculus. And then we do not start solving the problem from the start itself. We do not start solving the problem from the beginning itself. The moment where we feel that we should use calculus instead, we start from there, means we continue from there only and changing few of the thing into the dx dy whatever, and it converted into calculus. Means at the mid, if we think that this problem should have started from the calculus perspective, then we start from the beginning. No, we start from the beginning, and at the middle we feel that this problem should have been solved through calculus. At that moment, we transform some of the key concept in the mathematics. Wherever we are making calculation like division, we change it to differential calculus. Multiplication, we change it to integral calculus. Repeated summation, that also we can change it to integral calculus. And in that fashion, then we can continue. Anyway, we have talked about the area of the circle, and area of the circle is nothing but we divided this circle into n number of parts. What is n number of parts? N number of parts can be vertically, I can slice into n number of sections, or horizontally, I can slice into n number of sections. This is slicing as per the x-axis or y-axis. There is another axis here, and that is called polar coordinate system, where this is x-axis and one radius starts from angle 0 and it starts rotating like this. Here it makes angle theta. Now consider this is first part of this circle. This is a wedge, and then we continue like this. This is second part, third part, fourth part, fifth part, sixth part. Like we have n number of parts. We divided a circle into n number of parts where theta is varying. What I'm trying to say is, if this is x-axis, this is part number 1, then this is part number 2, then this is part number 3, this is part number 4. Like that, I divide the circle. Okay, so we divide the circle into many parts. Okay, and in that way, then we calculate the area of each part and sum it. Consider the area of ith part, first part, second part, third part. Ith part is ai. I believe I top, if I place it, is called superscript, and base is subscript or something like that. So capital A and bottom right small I, AI, AI. In that fashion, it becomes summation of I equal to 1 to n AI, where ith, where we have divided a circle into n parts. When it is in n part, then summation of all parts makes the full circle. What is the area of the ith part? The area of the ith part is 1 by 2 r square delta theta I. This is what we have computed. How we have computed? If this is the radius that starts from the beginning, and radius goes like this, okay, and at moment radius is here, and then it moves delta theta I and it stops here. This section is ith section of this area. This is radius, it moves delta theta I and it come here. This angle is delta theta I of the section I. This is the arc. Okay, one catch is r is not necessarily it will be constant. R can be variation over theta. If r moved theta angle, then r here is different and r is here, it is different. And then r moved delta theta I from here. Again r here and r here will be different. R can vanish completely when I move delta theta, means R is varying. In that fashion, what is the area of this wedge? Okay, what is area of this wedge? That if I know area of this wedge, similar fashion I can calculate area of all the n wedges, and I can simply sum it, that is I equal to 1 to n and area of ith wedge. I believe it is alright. Now, in that fashion, if I talk in that way, then what is the area of this? The area of this is, if I see this is a triangle, if I see this is a triangle, then this radius into, consider this r goes here from here and hits it at right angle. These are assumption. So R goes like this and hit this radius at 90 degree. In that fashion, if delta theta I is very small, it will behave like a straight line and falling perpendicular on this line. In that case, this circle, this triangle area will be this, that is width, this as height into this line into this line by 2. This line, if I talk, then it is this line into delta theta I. That is R1 delta theta I is the arc into R2 is the net area by 2, because this height and this length and this length, if I multiply, it will give area of a rectangle. We want half of it, that is triangle. So more or less the ith section area is 1 by 2 R2. Radius, when it enters the ith section, radius is R1. This is R2. So R2, 1 by 2 R2 into R1 delta theta I. That is the area of ith section. Now I can say the area of full circle is summation of I equal to 1 to n. Summation of I equal to 1 to n. AI, area of the ith section. That is 1 by 2 R2 into R1 delta theta I. R2 is function over theta. R1 is function over theta. Or we can, better way, we can replace R1, that is the first radius. If this is x-axis, then radius is going in a circular fashion, and here it is angle theta. Then R1 is, consider R is function over theta, f theta, small f bracket theta bracket close. Radius equal to function over theta. We have many times we have given example as if r equal to cos theta or if r equal to sin theta, they form circle again. If someone draw a curve where r equal to cos theta, if someone draw a curve where r equal to sin theta, it will form a circle only, but it will not be centered at the origin. It will be shifted circle. Someone can draw r equal to 1 plus cos theta also. It will make a closed loop, but it will not be exact circle, something like that. So someone can try in this fashion. No one stops anyone. Okay, anyway. Now, if I see the area of the ith wedge, then that is 1 by 2 R2 into R1 delta theta I. R1 can be said as function over theta. In that sense, R2 can be said function over theta plus delta theta I, because if this is R1 and this is theta, then this is function over theta. R1 equal to function over theta. Then it moves delta theta I. This is R2. R2 is function over theta plus delta theta I. If delta theta I is very small, these are assumption only. Then we can say that R1 and R2, they are function over theta. The way theta is growing, they may change. We can just write function over theta. In that fashion, the ith section of the subsection of the circle, we have made n subsection of the circle. The ith section area is 1 by 2 function over theta into function over theta into delta theta I. That is 1 by 2 function over theta whole square delta theta I. Means full area of the circle is 1 by 2 function over theta when theta equal to 0. Delta theta 1 plus 1 by 2 function over theta, where theta is delta theta 1. It shifted delta theta 1. Delta theta 2 plus 1 by 2 function over delta theta 1 plus delta theta 2 function over delta theta 1 plus delta theta 2 whole square. So first one, if I see this summation, 1 by 2 function over theta whole square delta theta 1. where theta is 0, plus 1 by 2 function over delta theta 1 whole square delta theta 1 plus 1 by 2 function over delta theta 1 plus delta theta 2 whole square delta theta 2 plus at the end 1 by 2 function over delta theta 1 plus delta theta 2 plus delta theta n minus 1 whole square, then delta theta n. Okay, this if I now this is the net area of the circle. I believe it is all right. This is the net area of the circle. Okay, can I place this? Can I place this in a form that is computable? Now, how someone can calculate? Consider n is 5,000. 5,000 times we divide it. Can someone calculate it n times? Not possible. So we have to bring it into calculus. Calculus says you can divide it into n number of parts where n tends to infinity. If it is n tends to infinity, summation of I equal to 1 to n where n tends to infinity, then 1 by 2 function over theta whole square delta theta I. If this is the case, then delta theta I can be written as d theta. This is what calculus says. It can be written as d theta function over theta whole square. Now it can be summarized as integration integration sign for theta from one point to another point. Okay, whatever is the limit. If circle is going like this, then theta is growing like this, and then it is coming, then it is full theta. I won't say it is 2 pi. We have seen cases where in pi angle only it makes a full circle, where r equal to cos theta. If I draw r equal to cos theta, then r will go like this 90 degree, and then it will go like this again 90 degree, means r goes like this, r equal to cos theta. This is origin. R goes like this, and here start increasing the angle, and R starts diminishing. And when angle 90 degree, R is 0. It forms like this. And then R start growing again, and R become negative when theta grows. And when theta is 1 pi degree, R is maximum, that is minus 1. If I take positive R, R will come this side, and it will form the complete circle. Now we can say that summation of I equal to 1, I equal to 1 to n, 1 by 2 f theta whole square delta theta I is integration where limit is for theta, and then it will become 1 by 2 function over theta whole square d theta, where theta goes from 0 to pi. Someone can calculate, and it will give the area. Okay, now to make people believe that whatever we have found the ith section area is correct or not, then we used a fundamental called vector. What is vector? Fundamental is, okay, we will talk about this. How we came in the past video, we have proved it that through vector fundamental and then basic integration, we got the kind of surface area as 1 by 2 integration 1 by 2 r square d theta. That confirms that our ith section is indeed 1 by 2 r square function over theta whole square delta theta I. That is correct. Anyway, we will do this calculation again for the line fundamental. How to calculate circumference? How to calculate circumference of a circle? If this is x-axis, then from here I can make a small division. I make n number of division on the circumference. So in that fashion, this is the first division, second division, third division, fourth division, fifth division, sixth division, seventh division, eighth division. N number of times, n division we are making on the circumference of the circle. N division. First, second, third, fourth, fifth, sixth, seventh, eighth. N division. Now, what is the length of ith division if I cut this circumference into n division? What is length of this ith division? We have calculated it earlier. The length of this ith division, if I see that circumference, consider this is the ith division. Now we are talking about this arc. What is length of this ith division? Then the way we did area calculation of the area, ith division area, in that fashion it will be r into delta theta I, but it's not. Okay, why it is not is, if I'm trying to calculate arc length, and if I say r into delta theta I, then it is considered that r is constant, but r is variable. In that way, this arc will not, when we say what is the length of the arc, then we say r delta theta I. If this angle is delta theta I for the ith section of the circumference, then r into delta theta I is the arc, but that is not true, because r, the way r is changing when we change the delta theta, we change the theta. Here at angle theta from x-axis, r is r1. But there is a high chance that when we move delta theta, r will become 0 as per the r is function over theta. In that way, r into delta theta I is not the circumference arc. It will be different. It is actually r1 only. If this is r, then r into delta theta I, it vanished. Once we started moving, the radius started becoming less till we reach delta theta I, it becomes 0. In that fashion, the arc is, what arc we are talking is r1 only, but we are talking arc as r1 delta theta I. So when radius is function over theta, in that fashion we cannot say that our arc is r into delta theta I. R is not constant. If it is constant, then we can say r delta theta I. In that fashion, how we can say that what is our arc? Then we say this is x-axis. Now consider this point is x1, y1. This point is x2, y2. Or this point is x comma y. This point is x2, comma y2. Now this is radius at x-axis. It moved angle theta and it made many sections on the circumference. If this is the circumference, okay, if this is the circumference, if this is the circumference, then we make section on the circumference. We are talking about the ith section. So in the I, when we talk about the ith section, at that time it is angle theta from the x-axis. Consider this point as x comma y. If this point is x comma y, then this point is x2 comma y2. How much x shifted? Means if I make interception on x-axis, this will be x, and interception on y-axis, it will be y. Here if I make interception here, it will be x2 and it will be y2. How much x changes when we move from x comma y to x2 comma y2? There is a delta x movement and there is a delta y movement. Means there is a delta x movement along x-axis, that is x2 minus x, and there is a delta y movement, that is y2 minus y. Okay, don't take the minus or plus. So this is delta x and this is delta y. In that fashion, this arc, if I consider this arc as a straight line, if I consider this arc as a straight line, considering delta theta I is very small, all are assumption only, then this arc we can make it a straight line. This straight line is the hypotenuse of the triangle, that is delta x and delta y. Now this two radius may not be the same. We have said the radius may become smaller if I move in theta, because radius is function of over theta. Still this arc, if I take, or a straight line if I connect, this straight line will behave like a hypotenuse of a triangle. One side is delta x and one side is delta y. Then this will again behave like hypotenuse. Means if r is varying with the theta, still the change, still the arc length, ith section, if I divide into many sections, the ith section arc length is still delta xi whole square plus delta yi whole square root, that is the hypotenuse. Now we got the arc length of the ith section. Now we can make a summation. Summation sign, that is summation, I believe sigma sign, summation sign I equal to 1 to n, and then what is the arc for the ith section? Square root delta xi whole square plus delta y whole square, delta yi whole square. This is the arc. If I keep adding for all the sections, I get the circumference. Okay, in that fashion, we did many things here. We did many things here. Now, if I want to convert it into integration, then delta xi will become dx and delta yi will become dy. Okay, in that fashion, it will be integration sign square root dx whole square plus dy whole square. Okay, then someone can proceed in this fashion only, considering y equal to square root of a square minus x square. If it is a circle, then x square plus y square equal to a square. Y equal to square root of a square minus x square. Someone can continue like this also. Square root of dx square plus dy square. Y equal to square root of a square minus x square. Okay, whatever it is. The square root of dx square plus dy square can be written as dx I can take out. It becomes a square root of 1 plus dy by dx whole square, and outside dx will be there because we dx we have taken outside. How much it will be? A square root of 1 plus dy by dx. How much is dy by dx? If y is square root of a square minus x square, dy by dx will be minus x by square root of a square minus x square. Now it will become a square root of 1 plus dy by dx whole square, x square by a square minus x square. It will be a by square root of a square minus x square dx, where x is from minus a to a, where x is from minus a to a. In that fashion, it will give the circumference of the upper layer only, because we are calculating dx from here to here, a to minus a or minus a to a. We are not making a full round. A to minus a will go like this. If I say a and back to a, then it will be full circle. A to minus a, x will go only half. Whatever comes, we have to double it, and it gives the circumference of the circle, whatever it is, whatever it is. Now, someone can proceed here in the angular fashion also. What is angular fashion? Consider x equal to r cos theta. Consider x equal to r cos theta. Consider like that, because we can describe any Cartesian coordinate system into polar coordinate system as far as circle is considered. Consider x equal to r cos theta, y equal to r sin theta. If I do like so, then x square plus y square equal to a square. It will be transformed into circle where radius is r and angle moves from theta from 0 to 2 pi. Makes sense? Now, in that fashion, dx will become d of r cos theta, dy will become d of r sin theta, where r is function over theta. R is not constant. Consider a circle where r is function over theta. In that fashion, if I say dx, then dx will become d of r cos theta, that is r into d of cos theta by d theta plus cos theta dr by d theta. Then dx would become r minus sine theta, r minus sine theta plus cos theta dr by d theta. Similarly, dy will become r d sine theta by d theta, because y equal to r sine theta, dy equal to d of r sine theta. It will become r d of sine theta plus sine theta d of r by d theta. Then it will become something like r cos theta plus sine theta dr by d theta. I believe it is all right. At the end d theta, at the end d theta, y at the end d theta. If I have x equal to r cos theta, then x can be rewritten as dx by d theta into d theta. Makes sense? If I say x equal to r cos theta, then I can say I can provide derivative on both sides. Then d of x equal to d of r cos theta. D of r cos theta can be written as d of r cos theta by d theta into d theta. And this is how we did the derivative. We calculated the derivative, but at the end we have to place d theta. In that fashion, now we can place against dx whole square plus dy whole square root. Now dx whole square, dy whole square, there d theta will be there, d theta will come out. At the end we will have to write d theta. Now square root of r minus sine theta, square root, and inside that dx whole square. What is dx? R minus sine theta plus cos theta dr by d theta whole square plus dy, that is r cos theta plus sine theta dr by d theta whole square, a square root, and outside d theta will be there. If someone settle it down, it becomes a square root of dr by d theta whole square plus r square. Someone can try. Okay, dr by d theta whole square, dr by d theta is anyway there. Dr by d theta whole square plus r square. Okay, square root and d theta. Someone can try like this. Okay, so how it will come, as we have r minus sine theta. First is r minus sine theta plus cos theta dr by d theta. Someone does whole square plus r cos theta plus sine theta dr by d theta whole square. If someone settle it down and place a square root, it will become a square root of dr by d theta whole square plus r whole square outside d theta. This is the this is considered as the kind of integration. If I have integration of theta square root dr by d theta whole square plus r square and d theta, then if I have divided into many sections, then the theta section, the ith section, if I divide circumference into many sections, if I divide circumference into many sections, the ith section length is if I now break it into summation, the summation of I equal to 1 to n, and then square root, and then dr by d theta, whatever is feasible, dr by d theta, dr by d theta. Someone can settle it down. Outside we have kept d theta. Outside we have kept d theta, that we can multiply it. It will become a square root of dr whole square plus r d theta whole square. I believe d theta, if I bring in, it will make ith section length as square root dr whole square. R of the ith section. R is varying, right? So if this is the x-axis, r is varying. What is the radius at the ith section? Okay, delta r of the ith section, dr whole square, delta r of the ith section. What is delta r? If this is radius when it enters the ith section and this is the radius when it exits the ith section, how much change in radius I see? Delta r of the ith section whole square plus r of the when it enters, that is r of the ith section into delta theta I. How much delta theta we move? Delta theta I whole square root. So that is the circumference of the ith section. Makes sense? How we started from the d delta x and delta y, and then we converge it into then we converge into integration, and we are trying to pull back the summation again. We are trying to pull back the summation again. If you are trying to pull back, someone can try directly also. What is delta x? Delta x whole square plus delta y whole square root was the ith section circumference. X equal to r cos theta, y equal to r sin theta. If delta x and delta y someone tries, it will come to this stage only. No need to come to integration and then go back to the summation. It will come here only. What it will come is ith section circumference or arc length is square root delta ri whole square plus ri into delta theta I whole square. This is the ith section circumference. But what is problem here? Problem here is there is assumption. What is the assumption? Assumption is while calculating the arc of the ith section, we took the arc, this is the arc, and we took arc as a straight line. That is the assumption. That's why delta x whole square plus delta y whole square equal to this straight line whole square. But this is an arc. This is not a straight line. We took assumption. If you see the area, ith section area, then we again took it as an arc as a straight line. And we took it is a perpendicular. These are the assumptions we made. Can someone prove that with the fairway, the ith section circumference is indeed square root of delta ri whole square plus r delta theta I whole square? Indeed, it is like that. We can prove it. How we can prove it? Now consider, now we started a discussion that for the ith section, we have a point here called x comma y. And another point in the ith section, we are talking about the ith section of the circumference. If we are talking about the ith section of circumference, then this is the ith section circumference. This is x-axis. We started chopping into many many sections in the circumference. This is the ith section circumference. This point is x comma y and this point is x2 comma y2. We made it very clear. It is not required that this length and this length are same, because radius may vary with the theta, whatever it is. What I'm trying to say is, if this is origin, then x1 whole square plus y1 whole square root, that is this length, and x2 whole square plus y2 whole square root, that is this length. It is not required that they are the same. Okay, in that fashion we have to proceed now. Now, if consider this is point P, then position vector. Now we will use vector here, because vector gives a very fine granularity, or someone can say completely accurate calculation as far as the direction is concerned. So consider this point as P. This point is P. Okay, if this point is P, then this is position vector. Consider this point is P2, then this is position vector. Now what is the concept here? Concept is how much this point P, that is x comma y, and change to x2 comma y2. If a point x comma y changes to point x2 comma y2, there is a length involved. But that length may not be a straight line, but there is a length involved when a point change from x1 x comma y to point x2 comma y2. Okay, what is the, now I address this change in this, we will address this, I'm sorry, this point is x1 comma x comma y, this point is x2 comma y2. Now idea is how much this point change, means this point change from x comma y to x2 comma y2 through a arc fashion, not through a straight line. If it is changing through arc fashion, then from x comma y it went to a point called x1 comma y1. Then it went to a point called alpha comma beta, or whatever it is. It went through many points. Finally it came to x2 y2. In that sense, now idea is what is the length that it proceeded, okay, before reaching to the x2 y2. That is the concept. That is also called what is the vector representation of this arc. Hope. What is the vector representation of this arc? How I can calculate this? Idea is, can someone calculate this arc length? This is the ith section arc length. If I represent this arc as a vector and calculate the magnitude of the vector, we get the arc length. Makes sense? If I represent any line, not necessarily a straight line, a curved line also. If I represent not approximation, exact. If I represent any curved line through vector, that vector will not be a numeric vector like 2i plus 3j, 4i plus 10j. These are the numeric vector and they represent a straight line. If I say I have a vector that is xi plus sin xj, this is called vector field or algebraic vector, where we, depending upon the x, the vector will start changing its direction. Every moment of x, vector direction will be different. It will exactly represent a curved line, a algebra vector. What is the vector representation of algebra vector representation of this curved line? If I'm able to find it, then if I'm able to find it, then calculating the magnitude of that vector will give the length. What is that vector? That vector is subtraction of this vector and this vector. If I subtract this vector with this vector, if this vector is P2 and this vector is P1, if this vector is P2 and this vector is P1, okay, then if I subtract this, then I may get, if I subtract this, then I may get another vector that is like this. Subtraction of one vector to another vector give the another vector. Makes sense? If I subtract this vector to this vector, it will give me another vector in this direction. If I add these two vectors, it will give me another vector from the middle. It will go like this, okay, or somewhere like this. But if I subtract this vector to this vector, it will give me another vector that will touch this line and this line. This is what we want. But that should be algebraic vector, not a numeric vector, straight line vector, whatever it is. What we want P2 minus P1. What is P2 minus P1? If I calculate magnitude of P2 minus P1, I get the arc length. Makes sense? What is P2 minus P1? P2 minus P1, if I say P2 minus P1, then I got the idea. The magnitude of P2 minus P1 is the ith section length. P2 minus P1, I can write as D of P. D of P means change in the P. Delta P, that is the better word. P2 minus P1 is delta P. Delta P means how much it changed. Make sense? If I say y2 minus y1, I can write as delta y. How much y change? Y2 minus y1 as delta y. X2, x minus x2, I can write as delta x. Similarly, P2 minus P1, I can write as delta P. Okay, what is delta P vector? If I know delta P vector, calculating magnitude of delta P vector, we will get the the circumference. Delta P I can write as delta P by delta theta into delta theta. Makes sense? Anything I can multiply and divide by the same thing. Delta P by delta theta into delta theta means magnitude of delta P by delta theta, whatever it comes, keep in magnitude region into delta theta, it will give the circumference of the ith section. Delta P by delta theta, I can write as dP by d theta. dP by d theta means if I make 1 unit of angle change, how much position vector is changing? dP by d theta. Makes sense? Okay, dP by d theta. Okay, we started that our arc length of the ith section is delta P. Delta P is delta P by delta theta into delta theta. Delta P magnitude, that is the arc length. So delta P will be a vector. Calculating the magnitude will give the ith arc section. Now in that section, delta P magnitude can be written as delta P by delta theta into delta theta. Numerator delta theta I can take outside. Delta P by delta theta magnitude into delta theta is the net circumference of the ith section. dP by d theta. If delta tends to 0, means it is very small, we can write as dP by d theta. We are not missing anything here. There is no approximation here. dP by d theta, magnitude of dP by d theta will give the it is called change in length vector. It is not the length, it is change in length into delta theta. Again it will give the length. What is dP by d theta? What is P? P is x comma y, dx, d of xi plus yj by d theta. Okay, x is r cos theta and y is r sin theta. Now we can write d of r cos theta I plus r sin theta j by d theta. What it comes? Someone can try its magnitude. Okay, its magnitude, if someone try, it will come exactly as square root of dr by d theta whole square plus r square d theta. Okay, means this is correct. What assumption we made that our ith section circumference is square root of delta xi whole square plus delta y whole square, considering arc as a straight line. That was perfect, knowingly, unknowingly. Okay, so I believe it is too much, but we tried getting back the summation through the integration. Idea is getting integration through summation. Okay, that we started making assumption that our arc is a straight line. In that fashion, arc behave like a hypotenuse of a triangle, and that triangle, one side is delta x and one side is delta y. In that sense, the arc length is delta x whole square plus delta y whole square square root. Okay, in that fashion, we saw that it becomes dr by d theta whole square. I'm sorry, delta r by delta theta whole square plus r square square root into delta theta I for the ith section. Now we started from the back side, that is integration, and indeed it is same. Okay, we'll try one more session. I'm not satisfied but we'll try one more session where we will directly talk about the arc vector. Here we have done P2 minus P1 to demonstrate it as arc vector. We will take directly as arc vector and we'll calculate its magnitude, and we will see what is the ith section magnitude. But all these are coming from the right hand side. Summation brings integration. Integration from the summation, but we know what is summation through approximation. We are bringing summation from the integration back, saying our summation approximation was indeed, it was all right. I believe it is all right. What we will do here, what we will do here is, for any line, if you watch our previous videos in called pseudo multivariate calculus, there we introduce a concept called length vector. Length vector means if I have a line, if I have a vector that connects two points, here we have vector connecting point x2, y2 and x comma y. What is the vector representation of this arc line? That is under question mark. What is the vector representation of this arc line? What is vector representation of any line that connects to point? Okay, consider this is origin and this point is x comma y. What is vector representation of this? Vector representation of this line is xi plus yj. What is the section of this line? What is the length of section of this line that is connecting 0 comma 0 to x comma y? Okay, the original question is what is the length of section of this line connecting point 0 comma 0 to point x comma y? First represent this as a vector and calculate the magnitude. Vector is xi plus yj. Magnitude is x square plus y square square root. No. What is the length of the section of this line from point x2 comma y2 to point x comma y? Represent it as a vector. What is a vector? X minus x2i plus y minus y2j. Okay, now compute the magnitude of this vector. That will be the length of section of a line, that is x2 y2 connecting x comma y. That is I believe x minus x2 whole square plus y minus y2 whole square root. If x2 y2 is 0, then it is x square plus y square root. Now another question is, consider that instead of a straight line, this is a curved line. This is a curved line. Curved line starts from origin and it hits a point called x comma y. This is a curved line. Now tell me the length of this curved line, not the straight line. Still we will go with the same fundamental. What is the representation? Consider this curved line. If I talk about a curved line that starts from x comma y and goes till origin, if it was a straight line, then it would have been xi plus yj. Okay, difference between a curved line and a straight line. If I see the straight line, then everywhere y by x is numeric, a number, and it is same everywhere. But if you take a curved line, then everywhere y by x is different. If someone takes a curved line and take any point on the curved line at x comma y and see what is y by x. Now take another point on the curved line at x comma y and see what is y by x. Take another point on curved line as y x comma y. See what is y by x. Every y by x will be different. That is difference between the straight line and curved line. In that fashion, we have to represent our vector in terms of y by x, because y by x is variable. Then whatever comes, that will make it represent a vector representation of curved line. That simple it is. If I have a straight line representation as a vector in xi plus yj, the curved line representation, to get the curved line representation, I have to take out x from here and make it in y by x. It will become I plus y by x j bracket close into x. Okay, now division will become differentiation and multiplication will become integration. Now the vector representation of a curved line is I plus dy by dxj bracket close into x into dx. That's it. Now this ith section curved line, if I am talking, then this curved line representation can be same thing, I plus dy by dxj bracket close into dx. Calculating this magnitude of this curved line will give the length. This is not available in any of this. Is the most perfect proof of the what is the line length of the ith section, that we will see. This is not available in any of the book. That if you want ith section curved line, then you represent the curved line through a vector and calculate its magnitude, and then that will be the length of the curved line. Whatever comes, then estimate it for the repeated summation, and that will be in terms of I. We are talking about I. That we will see. Please do not mind supporting us. +91 is the India country code. 9483160610 is the telephone number. +91 is the India country code. 9483160610 is the telephone.